Today, we offer you a deep dive into the digital transformation of 4GL applications using Lycia toolset. In this demo, you will observe how a legacy 4GL app's look, navigation, and search are modernized in a low-code way while preserving the existing business logic. How revamping your application in Lycia based on your 4GL code will save you costs and time, as you don't need to rewrite your programs in another language. How the 4GL app is made fully portable, cloud-based, and independent from other apps. How you can easily turn your 4GL apps into RESTful API web services and create definitions for them. How Lycia provides a smooth internationalization and localization for your applications. How your programs can use all the benefits of automated deployment, auto-scaling, load balancing, and fault tolerance with Kubernetes. How we provide an accordance with the accessibility standards for every program made using Lycia. Also, our debugger is there to assist with your 4GL development. This example program is an insurance module, written in Informix 4GL using the 4gen case tool. We are going to demonstrate how we have digitally transformed the entire program into a modern, cloud-based application, and how broad are the opportunities that come with using Lycia Development Suite. This is an old-fashioned search in the perform and a navigation through the records. In our transformation of this program, we preserve the business logic and also expand and improve the user experience. Now, meet the preview of that broker module after the digital transformation using Lycia. Now this app can be accessed locally or from remote instances and run right in the web browser. It combines the elegance and performance of 4GL and the strength of contemporary web technologies, including the power of CSS customization. The program controls have been redesigned into convenient menu and toolbar, with the existing navigation with keyboard controls intact. With Lycia, these controls are available for adding to every application and ready for both built-in and custom actions. Our low-code solution known as Lycia Low-Code can add a whole set of actions to any program with only a couple of lines of 4GL code, eliminating the need for dull coding of the toolbar-invoked actions. Observe now how we use a search filtering functionality with all the underlying business logic carefully preserved. For instance, let us use the class filter to invoke the lookups, organized into a multi-selection drop-down list. After applying a certain filter, we move through the records that fit the filtering condition. We have put the best of our profound expertise into creating efficient solutions, like an IDE for 4GL developers named Lycia VS Code Extension and the visual form editing tool, the Form Builder. Now we are going to use the latter for form editing. First, we invoke this tool from the Files context menu. The Form Builder has different views that provide full control over the form structure and look, and can also be used to define some of its behavior. When we select a form element, the Properties view displays the list of properties for that element. Using the Properties view, we change the text of the label we've selected. Let's turn another field from a text field into a combo box by right-clicking the item and then selecting the Morph option. Next, let's move some of the form elements into another area. In the left part of the Form Builder, there is a Form Structure view, displaying the form's contents as a tree. To create an additional area, we add an extra column to the container. Then we define the amount of the container area that each column will take. As our next step, we drop a group box container into the empty column and give it a title and an identifier. The group box can be folded at runtime if needed. Next, we place a grid panel container into that group box and add a title and an identifier as well. Then we add an extra column and a few more rows. Now we can drag and drop the items into the places we've prepared for them. As a finishing step, we align the items towards the top of the container. Let's remove the rows where the items used to be to tidy up the form. Now we have the layout we've intended for. Let's rebuild the program, deploy it, and run it. Not only have we transformed the program's look and controls, but we have also brought efficacy to its code. For any project, it is important for the code to be easy to maintain. The transformed application has only 170 lines in total in its main and function blocks. And now let's compare it to the stunning amount of resources the old version of the program required to run. For instance, the old version had separate files for different application levels, and they have several times more code in total than the entire Lycia 4GL file of that same application now has. Lycia has transformed the 4gen per form into an XML form file. All the foreign key primary key lookup table relationships, that is, the lookups and zooms, defined in the per form have been transformed into Lycia 4GL. The Lycia low-code engine processes this information at runtime and populates the combo box automatically and dynamically.
With Lycia Development Suite, your applications can use a variety of looks, from built-in styles and Querix public resources to your own custom themes. With the full support of CSS properties, Lycia grants you full freedom to apply even the most modern visuals. This application uses a modified style from the Querix public resources. This style has been made available to the application using the import statement of CSS. In this example, we can easily switch off a certain style and apply another one. Now that we have switched off the style that was imported, we can restart the application and observe that the default built-in styles are used. Now, let's apply a different theme for our application. We have created a CSS file in advance as a theme specific to the application and added the selectors and properties to achieve a dark theme look. Let's add that CSS file to the public resources the application can use and restart the application. Now, the dark theme has been applied.
With Lycia, you can ensure that your program will work with different locales. To have your program translated, you need to prepare a form file, a 4GL file, and a set of localized strings. For this example, we created a contact form and filled it with text fields and spinners. We have also added the menu actions, which will be located in the program's toolbar. Here, there are 3 locales and an extra option for triggering the defaults. The locale that will be displayed to the program user is controlled by one of 3 things: the language settings in the program user's browser, the locale set as a variable in one of the configuration files, or a special function that defines the locale. To provide the localized strings, we have created the localization resource files that contain the original strings as keys and the localized strings as values, 1 file per locale. The names of the program, the 4GL file, and the resource files must be the same. For the resource files, we add the locale indication to the end of the file name, for instance, N_US for the United States English. To retrieve the original strings, we open the form file in the form builder, find the text property of the label element of the form, and open the property editor. This text will be displayed at runtime and can be localized. To make the string available for localization, we add a % and quote marks. In the first line of each localization resource file, we add the name of the file. Then, after the curly bracket, we list all the original and translated strings. The original strings are the ones we have marked with % in the properties. The browser language is the very first thing the program picks up. In case the user's browser language is not among the locales we have covered with the localization files, the text of the label will be displayed as is, with no translation. In our example, the browser's primary language is set to United States English, so the program picks up the N_US locale from an appropriate resource file, and applies it to the label text. As it was mentioned before, there's a way to force a specific locale to the programs by setting an appropriate environment variable. For instance, let's set a German locale and see how it influences the runtime. Now, all the label text strings that have been provided with appropriate localization strings are translated to German. This variable overrides the browser language settings. The third way of setting a locale for the program is using a function. Even if the browser language settings and the environment variable are set to different locales each, the usage of this function will force a certain locale for this program independently from those. As we have assigned the function calls to the toolbar menu items earlier, here's how we call up different localizations for the form, by clicking the assigned buttons. As Lycia low code was created to speed up the 4GL development, it has a set of dialogues made for your convenience, and we have also added a possibility to localize them. To do that, use the translations setting of low code.
Lycia applications are ready for narration and open for accessibility. The CSS customization provides an opportunity to pick colors and contrast levels that fit accessibility standards. A screen reader can narrate the UI elements of 4GL programs created with Lycia. The program user can also move around the application with keyboard controls. We will now activate the Windows built-in narration tool and use it on our example program.
Scan mode, settings_translations_min. Next page, button. Edit, button.
In this example, we use arrow keys for navigation, and we can move both through the toolbar menu items and the form fields in that way. Let's select the Edit button to enter the input mode.
Scan off, edit, Querix, UK, Limited.
Then, using the keyboard arrow keys, we move down to the field we need to edit.
Edit, 50 The Avenue. 50 The Avenue selected.
The narrator assists the navigation by reading whole strings or separate letters if we move the cursor inside the field.
Space. E. 0, 5, 1. Company address hash 1. Edit, company name, image, button, image, header, main line, OK, image. Modify, do you want to save changes? Yes, no, cancel group, yes, button. Scan, settings_translations_min. 150 The Avenue selected, scan off.
Here's how Lycia can assist in creating accessibility-compliant applications so that every user's needs are met.
Any program in Lycia can be deployed as a web service. In our example, there is a program that has the main and function blocks, with the latter summarizing the incoming parameters and returning the sum. The compilation as a web service replaces the main block completely and makes the function available for web API requests. Let's compile and deploy this application as a web service by right-clicking the program and selecting the Build, Clean, Deploy as Web Service, and then the Build and Deploy option. Open any REST API tool and run the deployed web service using the Run prefix. In the response, we get the session ID and the status idle. This means that the web service has started and is waiting for further HTTP requests. Next, we call the function using the call prefix, the function name, and the parameter values 1 and 2. In the response body, the web service function returns the sum of parameters, that is, 3.
With Lycia, any programs and libraries you create can be easily turned into web services with a generated OpenAPI definition. The definition file is generated with just a single command, and can then be published. This ensures that any changes to the service are immediately reflected in the accompanying documentation. Here is an example of Lycia 4GL application we want to use as a web service. It contains a main block and a function named web_f_sum. Let's build and deploy the application using the program's context menu in FGL Project Explorer. Now, we can create a definition file using the deployed program by executing the following command, qrun -- swagger. In the end, we add the name of the program. As a result, we receive a JSON file in the current directory. It contains a description for that web service.
Let us show you the load balancing of 4GL applications with Kubernetes. First of all, we create a cluster for running containers in Google Cloud using the Google Kubernetes engine. We use a default configuration and specify the cluster name and location. Then, we fetch the cluster credentials to manage the cluster on the local machine. Next, we have to create a disk where we will deploy our application. We select the 10 GB option. Once it is created, we deploy the NFS server container for it to run in the cluster. In its basic configuration, we specify ports and file system type of our volume. Next, we create the NFS service for our cluster with the following configuration. Then we create a volume itself, which we are going to use for application deployment. Here, we specify the capacity and the access modes, and link this volume to our NFS server container. Now, let's move to creating Lycia runtime containers, which will serve our application. At first, we create a secret for our Docker Hub credentials and deploy our Lycia container. In the configuration file, we specify its name, the volume to attach, ports, and so on. Next, we create a load balancer service to distribute the incoming requests evenly across Lycia runtime instances. In the config file, we specify ports and session affinity types. We finish with a horizontal pod autoscaler service. Its purpose is to run new Lycia containers once the incoming load reaches a certain limit. In the configuration, we specify the minimum and maximum number of replicas and the memory utilization metric. So, let's check the dashboard of our cluster. In the dashboard, we can observe the number of running replicas and the information about memory utilization. If we switch to Google Cloud's Kubernetes Engine console, we can observe that same data, including the number of running pods and host IP address. Now, let's start an instance of our application and check the processes of our container. Here, the cron process is running, and the memory utilization starts to grow. Let's start another instance of the application. A new cron process appears. Next, we start more instances of the application. Once the memory utilization reaches 600 megabytes, a new container is created and is ready to serve new incoming requests. The Google Cloud Console also shows that there are 2 containers running. In the dashboard, we can check the status of the running containers and memory utilization. To make sure that the previously started applications are still running, we check the processes of our first container. Let's start a couple of new application processes and check that the application responds to our commands. If we refer to the processes view now, it will show that the second container is serving the incoming requests. Next, let's start a few more instances of our application and verify that the corresponding cron processes are started on the second container. We can also check the memory utilization for each of our containers. So, Both of the containers, the initial one and the new one, are serving incoming requests.
In this scenario, we are going through a simple example of debugging a small 4GL program with the following elements: built-in and custom variables of different data types and scopes, 3 program blocks, the menu block and 2 functions, menu dialog statement, dialog style message box. In our case, we will use the FGL winMessage function, case statement, for loop. We are going to set normal breakpoints, set conditional breakpoints using the hit count expression, use variable expressions, use variables with the onChange condition. We will also inspect program state variables, 4GL built-in variables like int flag, change variable values in the debugger child program, launched using the run statement, and use the debug console. We start by setting a breakpoint for the main function block by clicking the leftmost column of the editor view. The red circle appears, denoting a breakpoint. Then, using the FGL Project Explorer, we right-click the program and select the Debug as Web Application option. Let's move the tab to another browser window to observe both the client-side browser and the server program. The program has been suspended with an indicator around the breakpoint. It is now paused on the function entry. In the sidebar, there are several auxiliary areas. The first one is the Variables panel, organized by the variable scopes, global, modular, and local. In the global one, for instance, there are built-in variables to query the state of the application, like the int flag or Querix last exception. The next one is the watch panel, where you can add expressions. Then, there's a call stack panel, which shows the functions and programs in order of how they're called in the stack. And then there's a breakpoints panel, that stores the list of all the breakpoints you have in your program. At the top of your editor in debug mode, there's a navigation bar, which you can move around by dragging. Its first button denotes the continue action, which will resume the program until it hits the next breakpoint. The second button is step over, useful when you've hit the line with a function call and don't want to step into the function. The next button is called step into, which helps to step into functions. The step out button helps to leave the current function. Pressing the restart button will restart the debugging process, and the stop button will terminate both the debugger and the program. Now we're going to set a breakpoint on line 61, containing a function call, by clicking the leftmost column in the editor. We click step into to demonstrate how the debugger interacts with the program. Here, in line 42, we are going to modify the global records member GLint. We can observe it in the variables panel. The value is null at the moment. We click the step into button once more to go to the next line, and the variable's value changes to 1. As we move forward, the values change accordingly, and the variables panel reflects those changes. Let's change the value dynamically for the variable in line 51. After the program has gone through the value assignment, the value is 1000. With debugger functionality, we can change it to any other value. Now we will press continue for the program to continue until it hits the next breakpoint, which is now on the call of the function named myLoops. Let's step into that function. The debugger moves us to the function, which contains loops. Here, we will demonstrate conditional breakpoints. The first one is the hit count expression so that when the loop had its third iteration, the program run would break. We place a breakpoint within the loop by clicking the leftmost column, then right-click the very same spot and select the Edit Breakpoint option. From the drop-down list with the break conditions that appear, we select the hit count one, and in the field beside that drop-down list, we specify the number of iterations and press enter. In the next loop, we set a breakpoint, but this time we specify the expression to break on, I greater than 3. Then we're going to add one more break. We can right-click the Global Records GLint member, and select the Add to Watch option, for the watch panel to display the value of an expression in the program's current state. In the Variables panel, we right-click the value and select the Break on Value Change option. If this value changes, the program run will be suspended. Next, we click the Continue button of the Debug toolbar. The debugger stops at the first loop, and the panels in the sidebar provide the information about the variables. We click the Continue button, and the next stop appears on the condition of I greater than 3, which we can also observe as a pop-up hint when we hover over the variable. With the next click of the Continue button, the variable's value is 5. As we click Continue again, the program stops at the last condition fulfilled, at the GLint record member change. In the Breakpoints panel, you can disable a breakpoint without deleting it by unticking its box. Once we have disabled the breakpoint, we click Continue. The program shows the message box. Note that when there's a dialog box active in the program, the debugger has no control over the program as it is the client-side functionality. You cannot query the program variables from the debugger's sidebar, and no program state is displayed. In this situation, we click the Pause button in the debugger toolbar and proceed with the dialog, and as soon as the dialog returns control to the server-side program, the debugger is stopped. The pointer is now at the line where the message box functions code is. We click Continue, and now we're in the menu statement. Next, we click Pause and then run the child program from the main programs toolbar. Now the debugger is on the menu statement. Let's step into it. The pointer is on the line with the menu choice variable. We click Step into once more, and now the debugger is on the run statement. With one more click of the Step into button, we're in the child program, Debug Tutorial Run. Now we can observe the stack panel. It shows the debug tutorial program, the main one, and the program we're in now, Debug Tutorial Run. We select it and click the Pause button. Then, we go to our Programs dialog and click the OK button. Now we're in the source code of our child program, more specifically, in the main function. If we click the Step into button, the debugger will stop on the loop. We click Continue, and the child program is called. Let's pause, click OK in the Programs dialog, and click Step into afterward. After that, the debugger returns to the main program. Next, we are going to call a function with a very long loop to simulate a situation when the program is doing something and should have finished by a certain moment, but it hasn't finished and there's a need to find out why. When we click the button that calls that function, nothing happens in the window with the program running. Let's pause the program, and observe where is the program now. We can hover over the variables and get the values. Variable C is now on the iteration of about 120,000. Additionally, we can investigate using the debugger panes in the sidebar. Let's click Continue for the loop execution to resume. Those are the basics of working with Lycia debugger. It also has one more awesome trait, the possibility of attaching the debugger to a remote process and performing the debugging remotely, when the development seat is on an instance different from the production or testing server.
Let us show you an AI assistant that can be invoked right from your 4GL application. In this example, the AI has analyzed the database provided to it, and now it can process different requests, deliver analytical excerpts, filter data, and answer specific questions. Let's task it with the following request. Which top 5 claims have paid amounts exceeding the reserve value, along with the insured's number? After processing the request, the AI returns the numbers of the claims that fit the condition along with the paid and reserved amounts. Next, it highlights the sum that may indicate a high-risk event for re-estimation, identifies a client that may require closer attention, and accents the claims that have reserves equal to 0. Moreover, the AI can provide additional advices for a more thorough analysis. This AI integration will shape the next-gen future for your applications with excellence at a hand's reach.
For years, our technical team has guided many companies through application transformation and migration to the cloud. The Querix cloud solution provides you with a range of benefits right away. First of all, the onboarding is fast. The developers can start coding instantly from any web browser, as no local setup is required. Second, we make sure there's an enhanced, real-time collaboration and no app downtime. Third, the scaling is based off your actual usage, ensuring cost efficiency. Lycia is the ultimate adaptive 4GL solution. It enhances productivity by providing low-code development techniques to accelerate time to market. It uses a flexible approach to your app's digital transformation to meet your specific requirements. Lycia also offers a seamless web service integration with an automatic REST API creation at app deployment and the CI/CD approach. Besides, every application built and deployed using Lycia is provided with advanced UI features, as those are expected from any modern application. With Lycia, you'll also be able to savor the exciting integration of 4GL with AI. You will not only receive all the advantages of Lycia as a 4GL tailored IDE, but also a first-class 360-degree service. Querix embodies decades of accumulated experience with Informix applications, provides personalized support and consultation, offers database and OS porting services along with the robust security and authentication solutions. On top of that, we offer you our deep web development expertise with CSS, themes, graphical forms, client-side JavaScript, and other technologies and solutions. We take care about the efficient application transformation and functionality extension, code review and enhancements, comprehensive documentation creation, customized graphical menus to launch your programs, and personalized training. Lycia can elevate your app with all the benefits of containerization, consistent and isolated environment, cost-effectiveness, fast deployment, and mobility, the ability to run your applications anywhere. Lycia offers an extensive support of containers and virtual machines. Also, you can only choose to install the Lycia components you need, use any Linux flavor, and utilize rich and convenient command line interface. Balance the load and use your resources most efficiently with Lycia and Kubernetes. We provide load balancing and high availability of your apps, hot deployment and, thus, no downtime, and a metrics-based auto-scaling. Kubernetes ensures portability and flexibility, rapid scaling, and a capability to operate cloud-native applications regardless of the environment and underlying infrastructure. API is the future of a distributed computing. It provides a better system reliability due to the client-server autonomy, a uniform interface as a standardized way to communicate, a layered architecture for system scalability and security, and stateless interactions for performance and reliability. We made it possible for each program built using Lycia to become a web service after just a simple compilation. You can expose any function by adding the web_prefix and use our REST API methods for the program to communicate with third-party web services. So, summarizing Lycia Development Suite's capabilities and features, it will assist you in transforming your 4GL project, preserving the business logic. With Lycia, you'll be able to work with the same database, recompile and deploy your program to the cloud, extend its visual look with XML and CSS, make a responsive full-screen mode layout. You also can choose between developing programs locally or remotely. You will enjoy VS Code's convenience while editing and debugging 4GL programs, and create new forms easily with a visual tool for their creation, the Form Builder. You'll be able to create and publish web services with the REST API. To the top of that, Lycia facilitates extending the functionality of existing and new program sources in a low-code way, with our amazing assistant to tackle repeating and typical coding tasks, Lycia Low-Code. Lycia modernizes legacy Informix applications, bringing them up to par with modern developments, thus saving significant development costs. Lycia Development Framework offers a contemporary software development platform with a CI/CD approach, making it a valid choice for modernization projects. All applications developed with Lycia inherently feature web services with REST API, facilitating easy integration with other applications. Security measures such as encryption, SSL, and MFA ensure robust protection for the applications. AI and cognitive AI capabilities allow applications to learn from business logic and generate more accurate responses, enhancing user experience through API integration. The new powerful AI, integrated with 4GL programs, can produce important insights from the business logic in the apps. Analytical data, tailored per a specific request, prognoses, and advices. Also, the programs created in Lycia can support people of all abilities by following the accessibility standards. Lycia. For GL Redefined. Find our demo and training videos, documentation, and other information on Querix website, LinkedIn, YouTube, and Facebook, or contact us directly, and we'll be happy to help.